Have you ever wondered how the internet works? How does data travel from one device to another across the globe? The answer lies in the complex system of networking that underpins the internet and other computer networks. At the heart of this system are network layers. In this video, we'll be exploring what network layers are and how they work. We'll take a beginner-friendly approach to this topic, so don't worry if you're new to networking. By the end of this video, you'll have a solid understanding of the different network layers, what they do, and how they work together to create the internet as we know it. So let's get started. There are two primary models for understanding network layers: the OSI model and the TCP/IP model. Both models define a set of layers that organize the flow of data through a network. The OSI model has 7 layers, each with a unique set of functions. The physical layer deals with the physical transmission of data over the network, while the application layer is responsible for user-facing applications. The layers in between handle various tasks such as addressing, error detection and correction, and data transfer. The TCP/IP model, on the other hand, has 4 layers: network interface, internet, transport, and application. The transport layer is similar to its OSI counterpart, and the application layer serves the same purpose as in the OSI model. While the OSI model is more comprehensive and widely used in academic settings, the TCP/IP model is more commonly used in practice, especially for internet-based networks. Despite the differences between the two models, both provide a useful framework for understanding how data moves through a network. Let's have a look at the different layers in the models. The physical layer is the first layer of the model, and it's responsible for transmitting data over a physical medium, such as cables or wireless signals. At this layer, data is represented as a stream of bits, and the physical layer is responsible for encoding these bits onto the physical medium. Different technologies are used at this layer, depending on the type of medium used. For example, twisted pair cables use different encoding schemes than fiber optic cables. The physical layer also deals with issues such as signal strength, attenuation, and interference, all of which can affect the quality of the data transmission. By ensuring reliable transmission of data at this layer, higher layers in the network can build on top of it to provide more advanced networking functions. Next is the data link layer, and this is responsible for transferring data between adjacent network nodes. At this layer, data is framed into packets, which are then transmitted over the physical medium. The data link layer also provides mechanisms for detecting and correcting errors that may occur during transmission. For example, if a packet is corrupted during transmission, the data link layer can use error detection codes to identify and discard the corrupted packet. If the packet is important, the data link layer can also use error correction codes to attempt to correct the errors. The data link layer also handles flow control, which helps to ensure that data is transmitted at a rate that can be handled by the receiving node. By providing these important functions, the data link layer enables reliable transmission of data between adjacent network nodes. The third layer is the network layer, and it's responsible for routing data between different networks. At this layer, data is transmitted in the form of packets that are sent from one network node to another. The network layer is responsible for determining the most efficient path for data to take between networks, and it does this by using a routing protocol, such as OSPF or BGP. The network layer also uses logical addressing to identify different network nodes and to ensure that data is sent to the correct destination. Internet Protocol (IP) is the most commonly used protocol at this layer, and it uses IP addresses to uniquely identify devices on a network. By providing routing and addressing functions, the network layer enables data to be transmitted between different networks, making it a key component of the internet and other wide area networks. The transport layer is the fourth layer of the model, and it's responsible for ensuring reliable transmission of data between network nodes. At this layer, data is segmented into smaller units, known as segments, which are then transmitted over the network. The transport layer also provides mechanisms for ensuring that all segments arrive at their destination in the correct order and without errors. For example, the Transmission Control Protocol, TCP, is a commonly used protocol at this layer, and it provides error detection, retransmission of lost segments, and flow control to ensure that data is transmitted at a rate that can be handled by the receiving node. The User Datagram Protocol is another protocol at this layer that is less reliable, but provides lower overhead and faster transmission of data. By providing these mechanisms for ensuring reliable transmission of data, the transport layer enables applications to exchange data without worrying about the details of network communication. Finally, there is the application layer. It's responsible for providing services that allow applications to access network resources. At this layer, different protocols and services operate to provide specific functions, such as email, file transfer, or web browsing. Some of the commonly used protocols and services at this layer include the Hypertext Transfer Protocol, HTTP, used for accessing websites, the File Transfer Protocol, FTP, used for transferring files between computers, and the Simple Mail Transfer Protocol, SMTP, used for sending and receiving emails. The application layer is where most user-facing applications operate, and it provides an interface between the network and the user, allowing them to interact with network resources in a meaningful way. By providing these services, the application layer enables users to access and share information across the network. Network layers are a fundamental concept in computer networking that allow for the efficient and reliable transmission of data across networks. The OSI model and the TCP/IP model provide a framework for understanding the different layers involved in network communication, from the physical layer that handles the transmission of bits over a physical medium, to the application layer that provides services to applications. Understanding the role of each layer can help us troubleshoot network issues and design more efficient network architectures. I hope you have enjoyed this video, and thank you for watching. If you have any questions or comments about this video, please feel free to leave them in the comments section below. And don't forget to subscribe to our channel for more informative videos on machine learning and related topics.